RedisAI allows you to use Redis as the model server for AI, doing wicked fast inferences, which is pretty cool. But how do you actually do it? Well, let's find out and classify some flowers while we're at it. Today, we're going to check out in detail the Redis commands used to manipulate tensors, manage models, and perform inferences. Not sure what I'm talking about? Watch my previous video on RedisAI, where I go over the core concepts. Then come back here and learn how to do it. With flowers. No worries, I'll wait. Building a model to classify the species of an iris from its physical characteristics is a classic problem for students of machine learning. You can't go wrong with the classics, so I'm going to use this problem as we explore the commands for tensors, models, and inferencing. To classify an iris, we need 4 specific measurements: the width and length of the sepal, that's the bit that holds the flower, and the width and length of the petals. You know what those are. All in centimeters. These measurements will make up our input tensor, which I'm going to show you how to load. But before we stop to measure the flowers, we need to get RedisAI up and running. I like to use Docker for this. First, I pull the latest version of the Redis mod image from Docker Hub, as it has several popular modules for Redis baked in, including RedisAI. Then I run it, instructing Redis to load the RedisAI module, and instructing RedisAI to load the ONNX backend, since we'll be using an ONNX model to classify our irises. Now that we have RedisAI up and running, let's take a look at tensors first. Remember, tensors are the multidimensional arrays we use as the inputs and outputs of our models. There are 2 commands for working with tensors: AI TensorSet and AI TensorGet. As you might imagine, these commands set and get tensors. We'll set a tensor first, that way we can get it later. You gotta have a thing to get, right? The TensorSet command, like most Redis commands, is followed by a key. We'll call ours irisin, since it'll have the input data for our iris classifications. The next argument is the type of number we want to store in the tensor. The entire tensor is made up of a single type. The choices for these numbers are the common varieties of floating point numbers and signed and unsigned integers that we know and love. Our iris measurements are in centimeters, and the model expects floats, so that's what we'll specify. After the type, we'll specify the shape of the tensor, 1 number for the width of each dimension. The iris model can classify multiple irises, so let's classify 2 of them. Each iris has 4 features: the lengths and widths of the petals and sepals in centimeters. 2 flowers and 4 features gives us a 2-dimensional tensor with a shape of 2, 4. Next, we specify the actual values of the tensor after the values keyword. We have 8 values in our 2x4 tensor. The first 4 values are the sepal length, sepal width, petal length, and petal width for the first iris. The next 4 values are the measurements for the second iris. To get our iris tensor out of Redis, we'll use the TensorGet command. We just enter ai.tensorget and the key name. Then we need to decide whether we want the discrete values or a blob. If we ask for the values, we get them back from Redis as an array. You'll note that these values are not exactly the values we used when we created the tensor. That's because they're floats, which tend to be a bit imprecise. But no worries, they're plenty precise for what we are going to do. If we ask for a blob back instead, we get back a string representing the blob, which, while not terribly great for us humans, is very useful when you're integrating RedisAI into an application. And of course, if we can get a blob, we can set a blob. With AI TensorSet, you can specify blob instead of values to set a tensor with a string representing the blob. Again, more for the applications, less for the humans. When we're using TensorGet, we can also ask for metadata about the tensor. Just pass in the meta option, which will return the type and shape of the tensor. We can even get the metadata and the data in a single call. Just specify meta in either the blob or values option, and RedisAI will dutifully return them. So that's tensors. Now let's load our models so we can put those tensors to use. Models are loaded with the MODELSET command. AI.MODELSET takes quite a few arguments, so let's quickly go over them one by one. First, we provide the key to store the model in. We'll call it iris, since our model classifies irises. Next is the backend for the model. Our model is an ONNX model, so we specify ONNX as our backend. The argument after that allows us to state whether the model makes inferences using the CPU or the GPU. Our model was built for the CPU, so we specify CPU. Next, we want to provide the actual data for the model. We have to do this as a blob, so we specify blob and follow it with the data for the blob. Whoa, that is hideous. There's no way anyone should be expected to type this out. I mean, I even copied and pasted it to get it into the video. Fortunately, we can load the blob for the model from the file system instead. Assuming we have a file named iris.onnx, which I've provided on GitHub for your use, we can use standard in to load the model instead. We do this not from within RedisAI, but by invoking RedisAI from the command line with the -x switch. -x tells Redis to read the rest of the command you've given it from standard in. We make this standard in the bytes of the model using the redirect operator, and it just works. Way easier. Now that we've gone to all that trouble to set up a model, let's delete it. Just kidding. But if you do need to delete a model, use the MODELDELET command. It's just ai.modeldel and the key to delete. We have one final command to look at, and this is the command that brings it all together. ai.MODELRUN. MODELRUN makes inferences against models. To use it, we specify the key containing the model, then the keyword inputs, and then the names of the input tensor or tensors the model requires. Our model requires but a single tensor, which we've already stored in iris.in, so we'll use that. A model will also create, as output, one or more tensors. We use the outputs argument followed by the name of those tensors. Our particular model outputs two tensors, one containing the inferences, i.e. the species of the iris, and one containing confidence scores for those inferences. So let's go ahead and run our model and see if we have iris setosa, iris versicolor, or iris virginica. We can look at the results in the iris inferences tensor using TensorGet. The metadata shows that we have received 64-bit integers with a shape of 2. So this is a one-dimensional array with 2 entries, one for each iris in our input tensor. The values of those 64-bit integers correspond to the particular species of iris. 0 is iris setosa, 1 is iris versicolor, and 2 is iris virginica. Looking at our results, we can see that the first iris is of species iris setosa, and the second iris virginica. Neat. So what have we learned? Well, we've learned how to manipulate tensors with RedisAI, and we've learned how to load models, use them to make inferences, and inspect the results. And we even learned a little bit about irises. If you want to play around with this stuff yourself, and really, you should, all the files you need, and code to build the models if you're so inclined, are out on GitHub. The link is in the description below. If you want to expand on this example, the link for redisai.io is also below. It has all the documentation for RedisAI that you'll need in your exploration. Most importantly, thanks for hanging out and learning about RedisAI. We've covered the basics, but there's much more to learn and more videos to come. Make sure you don't miss them by subscribing and ringing the bell to get notified. Thanks.